Hello, let's go ahead and get started on Notes 1-1, which means it comes from section 1-1 in your book. So the first term that we're talking about is a point. So you've known about points the whole time. Here's a point, E, F, G, H. Those are all points. How do we name a point? Well, if you notice on the picture, everything on here has a capital letter. So in your notes, a point is named by a single capital letter. So that's point D, point E, F, G, H. Those are the points. Now let's get to lines. Lines can, if I draw a single point, if I just had a point over here, I could draw any line through that point. But if I wanted to talk about a specific line, how would you know if I'm talking about this line or that line? Which line am I talking about? Well, if I told you another point on that line, that would tell you specifically which line I'm talking about. So to name lines, you need 2 points. All right? Any 2 points. It could be EF, FG, GH, EH, HG. Order doesn't matter, okay? Doesn't matter. So any 2 points, and that will name the line. By the way, when you have points on the same line, these are called collinear points, because co means share. Collinear points. Returning to our notes that you may be using, collinear points, a line is used to, oh, I forgot to answer this question. A line is named using 2 points. Write 2 capital letters, so let's go ahead and do this. This line could be E and G, all right? 2 capital letters with a blank over both letters, a line. Okay, but I'm not done yet. If I just leave it like this, it's something else that we're going to talk about, which is a segment. I need the arrows at the end of each line to indicate that lines go on forever without end. So they're arrows at the end of each line. Order doesn't matter, so if I look at the example here, E, F, and G are all on the same line. So's H, but I only left blanks for 3 letters. So you can use any 3 letters from that line. Now, another thing that's on here, that you may say, wait a second, there's something on there with no point on it, and that's this little letter here. That's another name for the line, name for the line. So I can use a lowercase letter, it's usually italic, so lowercase, and it's italic and it represents the entire line. So in this case, B is the same line as, say, FG. Those are exactly the same lines. By the way, I skipped this one up here. They want a point in this picture that is not on any segment or line. The only point that applies to is that one right there. That's D. So let's go ahead and talk about segments. So in your notes, if you look at it, there's a segment JK. So let's talk about JK. A segment looks a lot like a line, except that it does not go on forever. These points right here are very special. Those are called endpoints. Okay? They're called endpoints. And the way you do it is you take the 2 endpoints and you put a short line over both letters. So in here in your notes, representing the 2 endpoints and a short line. Now, do you think it really matters if I go JK or KJ? Are those the same or different line segments? Does this segment change if I put the K down first and then draw it to the J, or if I put the J down first and then draw it to the K? It doesn't. So those are the same segment. So you can say on your notes that order doesn't matter. Order doesn't matter. Now, if you're doing Cornell notes, you do not need to do the fill in the blank. I'm just putting them there as a help since some of you are using the fill in the blanks. So, like I said here, JK and KJ are the same segment. So JK, KJ. All right? Okay, so let's go on to rays. Rays are really interesting. They are a little different from lines and segments. a ray, first of all, is kind of like half a line. So it has a starting point, and then it has a direction, whichever direction you go to. So in our example, if you look on the paper, there's a ray here that I'm going to use, the one with the S and the T on it. But the starting point isn't the S, it's the T. The S, you can use any point on this side of the line. This gives direction, and this is the starting point. So when you are labeling, you always start with the starting point, the end point there. It's always TS, like that. It is not ST. This is not the same ray. Okay, so those are not equal. All right, so in our notes, if you're doing the fill in the blank, let's look. Order matters when naming a ray. First, write down the capital letter representing the end point. You might be tempted to say starting point, but technically the term is the end point. And then write down any other point on the ray. And I need to say it gives direction. All right, so if I look on this one, EF and GH. So if I'm going to go ahead and do it right here. This was a challenging question for some kids. EF and G and H. So let's say I picked a ray that was looking like this one. It's going to start here. Actually, I'm going to have it start here and go in this direction forever. You would probably say that that ray is FH, and you would be right. But that's not the only name for that ray. There's another name for that ray. What other point is in the same direction as H? G is. So that is the same ray as FG. Now you might say, oh, wait, one's shorter than the other, but not really, because remember, it goes on forever. Since they're both going on forever in that same direction, they are the same ray. So again, in your notes, FH, don't forget, it's hard for me to get the arrow on there, and FG. One way you know you're doing it right for starting rays is that they always have the same endpoint. If they don't have the same endpoint, you didn't start at the same spot. Now, this is not really in your notes, but I want to talk about it as well. What if I wanted an opposite ray, something that goes in the opposite direction from FH? Well, I'd probably start at I would start at the same point, and I'd go in the other direction. So I can say that FE, remember, start at the middle point, FE and F, doesn't matter which one, are opposite rays. Okay? Not in your notes, but something important to know. I can tell you it will show up on quizzes and tests. So those are opposite rays. So again, just going back to our fill in the blank notes, if you're doing that, I said blank names the ray in the diagram above, so TS, but ST does not. Okay? Now, next one, and I have a nice, let's talk about planes. Planes. What is a plane? A plane is a large, flat, infinite, goes off in both directions. Mr. Tran has a very good explanation on this in his video. So if I want to make sure that I have a plane, the easiest way to think of it is, can I put all the points in the plane in the same direction? So I have 2 points here. 2 points, definitely we said was enough to make a line. Is it enough to specify a plane? So hold on a second. I'm going to lift this up, pick that up. Can't this plane also go through those 2 points? And if I tilt it a little bit, doesn't that plane until I'm all the way flat? So there are many different planes that go through those 2 points. 2 points are not enough to do a plane. Well, what if I put a point right here? Is that enough to do a plane? Well, no, because I can still do the same thing. What's the problem with my third point here? The problem is my third point is collinear, so we don't really want to use that point. What if I decided to put my point over here? Can I still put my sheet of paper somehow to connect all 3 points? No. But can I put my sheet of paper one way that has all 3 points? Yes, completely flat. All 3 of those points are in the same flat surface, but the only surface they're on is this one right here on the paper. There is no other surface that comes out that they will be on. So in order to name a plane, you must have, and if you're looking at your notes, 3 non-collinear points. So I'll write it for you. 3 non-collinear points. They cannot be on the same line. Now, will collinear points be on the same plane? Sure they will. But to name a plane, you need 3 non-collinear points. Okay? All right, next one. So then how do we name a plane? So you need 3 non-collinear points. So I'm going to come up with this beautiful example right here. How do we name it? Well, I could say that 3 points. 3 points to name a plane. So if I'm doing the yellow plane, here are some of the ways I can name it. I can name it as plane FEH, or I can do GJI, or see this thing right here? This thing without a point? That's actually another way to name the plane. Normally it'll be script. It could be a plain old capital letter, but it's usually script. All right. So on our notes, if you're doing fill in the blank, plane, we'll say GJI, just to make it a little interesting. GJI and plane V are the same plane. All right. Now I'm going to go to the green plane. The green plane. Points blank, blank, and blank are coplanar. So I need to find 3 points that are in the green plane. That should be pretty straightforward. By the way, point D is only in the green plane in this drawing. Point B is only in the green plane in that drawing. They're both green, but not yellow. So I don't know if you can see how this surface is kind of coming out of the paper. We can't draw 3D very well, so we have to kind of pretend it with the 2D drawing, make it look 3D. So I'll just pick A, B, and C. All right? A, B, and C are coplanar, right? And they're in this green plane. They are plane T, or you could say tau. So A, B, and C are coplanar. Coplanar means share the same plane, and they are in plane capital T if you don't like the tau. All right, so they're in this plane, tau. Only points on blank lie in both planes T and V. So which points will fit inside both the green plane and the yellow plane? Well, the only points that do that are these points on this line. You see how that red line that I just drew? It's in the green plane and it's on the yellow plane at the same time. So any points on this line, GJ, lie in both planes. Now, here's a question. Can you use points A, G, and B to determine a plane? Why or why not? A, G, and B, let me go ahead and circle those in blue. A, G, and B. So if I were to kind of just draw it out to the side, this is what it looks like. Notice what did I do? I made a shape, didn't I? Ah, there we go. They're on a line. So can that determine a plane? So for example 1, hopefully you'll say no. Because remember, I could have a sheet coming out of the paper, and that wouldn't work. And the reason is because the points are coplanar.